Phil Sunshine was one of the original neonatologists in the country, arguably one of the very first here at Stanford. He taught me and many others something that was really important, and that is that all things led to the NICU. The NICU is the center of our world, and practice of neonatal perinatal medicine for the benefit of the babies was first and foremost. And then secondly, that was a clinical laboratory that needed to be used in a way that would advance the care in the field and contribute to better outcomes for babies. I was interested in the sciences, but chemistry was difficult for me in the beginning. And so I went home thinking I was failing in my father's eyes.
Then something happened that I think was magical. His father, who was a really accomplished pediatric surgeon, said to David, look, you're having trouble with chemistry and all these other subjects, but why don't you choose something that you really care deeply about and do it well?
And it was incredibly wise advice. And I took it, and so I studied philosophy and humanities at Stanford.
He became a humanist, and I think that impacted his career path in very significant ways.
I continued to take the sciences, and they got increasingly more interesting, and I was better and better at them. And so it was at that point that I made a decision to go to medical school, and I returned to the Northwest for that purpose. During my training at the University of Washington as an intern and resident, I got to see my father work, so I was able to actually see him operate on babies less than 1,000 grams with some of the conditions that we still are dealing with today.
He was probably one of the most unique people I've ever met. We were searching for a fellow to join our program, and I had a co-worker by the name of John Johnson. He and I were co-directors of the nursery. I was away, and David made a visit to Stanford, and he was interviewed by John Johnson. When I came back, John says, this guy Stevenson is something special. And we hired him immediately, and it was a slam dunk.
As I was practicing in this field from the beginning, I realized that my patients were getting smaller and smaller and smaller. Their total blood volume might be 2 ounces, and they would literally fit in the palm of my hands. Remember, there are supposed to be fetuses inside the womb floating in fluid, and that's not what they encounter when they leave the womb and they end up in an intensive care unit. So doing the things that we do to older children or to adults to get information from them, like drawing blood repeatedly, could exsanguinate one of these little people. Many of our contributions were just more generally to trying to take care of very small people, nourish them, and help them to avoid injuries by developing minimally invasive technologies that could allow us to monitor their circumstances and make better decisions about how to care for them.
He didn't really have an idea of research, but I said, you want to really work with an outstanding investigator, work with John Johnson. And John was interested in bilirubin metabolism. Premature babies are more susceptible to high levels of bilirubin, which can lead to brain damage to an entity called kernicterus.
It's probably one of the most, if not the most common problem that babies have, which is a transitional hyperbilirubinemia. Bilirubin is the jaundice pigment.
For every molecule of heme that's broken down to go to bilirubin, there's a molecule of carbon monoxide excreted. So if you can measure the amount of carbon monoxide in expired breath, you can see if it's broken down or it's not broken down or it's produced too much.
So little babies make trace amounts of that, and we developed detector systems for measuring parts per trillion of that small trace molecules. This is trace gas analysis using breath as a diagnostic source. And we can then identify babies non-invasively producing the pigment at a high rate before they become jaundiced. Now I know who is likely to get into trouble. And rather than being reactionary, I can be anticipatory. And the thing we've been working on for the last 30 years, and we're now very close to translating this into something that could be used clinically by everyone, is a way to modulate the production rates of bilirubin. And then we'll have a product that can be used in humans that will be able to treat babies who have high production rates before they become jaundiced, and the whole problem of newborn jaundice goes away.
Dr. Stevenson is the most visionary, impactful, empathetic, innovative pediatrician of our time. And what he does is he reaches out across this campus, finds the most brilliant scientists doing innovative work that can't even imagine applications in humans, let alone in neonates. It's an incredible demonstration of the power of his visionary approach. And long before MCHRI existed, and even well before the Prematurity Research Center, David was collaborating with scientists, whether it's in physics to invent this extraordinary non-invasive measure of structure and function in living beings using optical time-of-flight absorbance imaging, which was then used in neonates, or other revolutionary science that he did, in the 1990s and early 2000s. Those kinds of advances that took advantage of the talent across this entire campus became the playbook for MCHRI. That is absolutely single-mindedly what we focus on.
My entire career has been spent, what we used to say, crossing Campus Drive into the other part of Stanford to talk to chemists, to talk to engineers, to talk to applied physicists, working in those environments with them to solve problems.
What's really extraordinary is over 4 decades of discovery, he is still at the leading edge, whether it's how we use artificial intelligence for nutrition or advanced computational methods with the microbiome to be able to predict prematurity months before it happens, the notion of the transcriptomic clock with cell-free RNA. This is the most cutting-edge science that's happening on this campus, and it's right now.
So all these different levels at which we can measure biology, and that helps us understand what's contributing to the different kinds of preterm birth that we deal with, who might actually be headed towards an early labor and preterm birth. That would again revolutionize the field, because what would be better than knowing who is going to have a problem and then preventing them from having the problem in the first place?
He's done so much for the university and for the department and for the medical school. He's an unbelievable administrator. And he's taken really significant problems and be able to bring people together and solve them.
When I arrived in 2001, I was looking around for individuals who could really help reshape the medical school. And the first person I went to was David Stevenson. David played a central role in transforming the clinical faculty by elevating the role of clinical faculty, both in terms of their academic performance and in their clinical performance and in their role as teachers.
The roles I've sort of found myself in were not roles that were planned. They just happened because of people that I'd met, opportunities that presented themselves, and then a chance to work with other people to make the place that much better for everybody else coming behind me.
He can see what no one else can see, and he brings this optimism and this idea of limitless possibilities to the field.
He's developed the career of so many young people where he's helped them with their research, he's helped them get jobs, and I don't know what else to say. I just love the guy.
I learned from my mentors how important people are. In fact, if you have a legacy, it's not so much the device you invented, or it's the drug you discovered, or it's the pathway. It's actually the people that you leave that know things that you didn't know, that are going to be able to do things you weren't able to do. They're going to make the place even better than when they inherited it.